evaluation of problems on parabola. Example number 2. The equation of a parabola is y squared plus 6x plus 4y minus 38 equals 0. Find the coordinates of the vertex and focus and the equation of the directrix. Sketch the graph. Y is being squared, therefore, the parabola may open to the left or to the right. Our V vertex, HK, our F focus, H minus FK, our directrix, X is equal to H plus F, and our principal axis, Y is equal to K. So, the equation is given, that is y squared plus 6x plus 4y minus 38 equals 0. Okay. So, we will be converting this into this form. Transforming this into that form. So, that is y squared plus 4y. We group terms with y. And then, we transpose this to the other side, plus 38. Let us make this a PST. This is y squared plus 4y. Get half of this. That is 2 square it. And then that is 4. Negative 6x plus 38. What you add here should be added here also, so that the equation will not change its value. This is now factored as a square of binomial y plus 2 squared. Square root, copy the midside, is equal to negative 6x plus 42. Now, this is already converted into that form. We have to factor this. This is y plus 2 squared negative 6 x minus 7. Okay. So, we know that this one is negative. Therefore, our parabola will open to the left. Okay. So, our vertex is 7. And this one is negative 2. Since this one is plus 2. So, our vertex is 7, negative 2. So, our focus, the focal distance rather, is 4f is equal to the absolute value of negative 6. Because we know that, of course, the distance is always positive. So, this is 4f is equal to 6. Dividing both by 4, f is equal to 1.5. Okay. So, that is our focal distance. Now, let us now plot this point, the vertex, that is 7, negative 2. So, this is negative 2. 1, 2, 3, 4, 5, 6, 7. This one is your vertex. Okay. And then your focus will be H minus F. But we know already that the focal distance is 1.5. You just count it from here. That is 1 and then half. So that is half. Okay. So this one is our F, our focus. And this is our principal axis. So our principal axis is of course y is equal to negative 2. That one. Now, how are we going to find, of course, the directrix? If this one is 1.5, this one is also 1.5. Okay, this one is your directrix. And 7 plus 1.5 is, of course, 8.5. So, therefore, this is x is equal to 8.5. This one, h plus f. And then, what else? We know that the focal chord or the latus rectum is 6. The latus rectum is 6, meaning to say that will be 3 on both sides. So, 3 units from both sides. So, we have 1, 2, and 3. Okay. So, this one is 1, 2, 3. And then 1, 2, 3. This one. This one is your latus rectum or the focal chord. So, how do I draw the parabola now? This one is your parabola. Okay. This one is the parabola. Okay. So what is our vertex? Our vertex is 7, -2. Our focus is this one, which is 7 minus 1.5 is 5.5, -2. Okay? So, the vertex is 7, -2. Our focus is 5.5, -2. And the equation of your directrix is this one. X is equal to 8.5. And the principal axis is, of course, y is equal to negative. Example number 3. Find the general equation of the parabola whose focus is the point 43 and whose directrix is the line y equals 5. I have already located this point, and this is 4, 3, 1, 2, 3, 4, 1, 2, 3. Y is equal to 5. This one is the directrix. We know that directrix is found at the back of the parabola. So meaning to say, our parabola here will open downward. And the formula for that is x minus h squared is equal to negative. This one means it opens downward. 4f, this one is fixed, the 4 is fixed. Y minus k. So we will be looking for the vertex, which is hk. Okay. So we know that this one is the focus and this one is a point, of course, parallel to this. And we can identify the coordinates of this. This one is 4 and this one is 5. Okay. To find the vertex, we will be using here the midpoint formula. So the h is the x-coordinate of your parabola. So this is x sub 1 plus x sub 2 divided by 2. And your k is, of course, the y-coordinate of your vertex. So this is h now is equal to 4 plus 4. 4 plus 4 divided by 2. H is equal to 8 divided by 2. That is 4. And then for k, we have 5 plus 3 divided by 2. K is equal to, of course, 4 also. So meaning this one is your vertex. Your vertex is 4, 4. Your vertex is 4, 4. Now, how do we get the f? We said that the f is, of course, the focal distance. And that is the distance from the vertex to the focus. From there, we can use the quadratic formula. But through our figure, we can say that this one has length 1. That is the small f. But let us verify whether it is really 1 by using, of course, the distance formula. Square root of xx, 4 minus 4 squared, plus yy, 4 minus 3 squared. F now is equal to square root of 0 squared plus 1 squared. F is equal to 0 plus 1. F is equal to 1. Square root of 1 is, of course, 1. So we are now ready to substitute it here. This is x minus 4 squared is equal to negative 4 times 1 times y minus 4. Okay. So let us simplify it. This is x minus 4 squared equals negative 4 y minus 4. This one is the standard form, but we are looking for the general form. So meaning we need to expand this one. Let us expand this. This is x squared minus 8x plus 16. Square the first, double the product of the first and second, square the last. Equals negative 4y plus 16. So this is x squared minus 8x plus 4y plus 16 minus 16 equals 0. So this is x squared minus 8x plus 4y is equal to 0. So this one is the general equation of the parabola. If we'll draw the parabola, 4f is equal to 4. So 1, 2, 1, 2. This one is the parabola. Okay. And of course, this one is your principal axis. The principal axis is, of course, x is equal to 4. That's it.